Hey guys, welcome back to Error Math. Hope your studies are going absolutely fine. So in the previous videos we have covered all these topics, and in the last video we have solved exercise 3.2. So if you have missed any of these videos, the link is in the description. You can check those videos first and then come to this video. In today's video we are going to see what transpose of a matrix is and how symmetric and skew-symmetric matrix are represented. So let's get started. So the first topic here is transpose of a matrix. So definition देखते हैं हम लोग directly transpose of a matrix का. So if a matrix A of elements aij and order as m by n, then the matrix obtained by interchanging rows and columns of A is called the transpose of A. That means अगर हमें matrix दिया है एक A और अगर उसका हमें transpose find out करना है, so the transpose will be given by interchanging the rows and the columns of matrix A. And the transpose of a matrix is denoted by A dash or A raised to T. We usually use this A dash instead of A raised to T. So हम सारे videos में A transpose को A dash से represent करेंगे. So A transpose is in general number of rows और number of columns. वो अब change हो जाएंगे number of columns और number of rows में. That means यहाँ पे जो हमारा column है वो row बन जाएगा और जो row है वो column बन जाएगा. जल्दी से हम लोग एक एग्जांपल सॉल्व करते हैं तो इससे आपको पूरा समझ में आएगा कि ट्रांसपोज कैसे होता है. सो लेट अस टेक एन एग्जांपल. इफ वी हैव गिवन अ मैट्रिक्स A of order 3/2 having 3 rows and 2 columns, then the transpose of this matrix A will be A dash is equals to first row will become first column, second row will become second column and third row will become third column. तो ये हमने रो वाइज ट्रांसफॉर्मेशन देखा. अगर इसका कॉलम वाइज भी अगर देखेंगे तो हियर 2 कॉलम्स. तो यहाँ पे जो A में जो कॉलम्स है तो A ट्रांसपोज में फर्स्ट कॉलम विल बिकम हियर फर्स्ट रो एंड द सेकंड कॉलम विल बिकम सेकंड रो. तो ये बहुत ज्यादा इजी है, हमें सिर्फ यहाँ पे इंटरचेंज करना है रो का कॉलम में. सो दिस इज व्हाट अ ट्रांसपोज ऑफ अ मैट्रिक्स इज. वी सिंपली इंटरचेंज द ऑर्डर. जो 3/2 का ऑर्डर है ट्रांसपोज होने के बाद इट बिकेम 2/3 एंड जो एलिमेंट्स थे Aij, सपोज ये जो एलिमेंट है यहाँ पे इसका पोजिशन है A21 इन सेकेंड रो एंड फर्स्ट कॉलम. तो ट्रांसपोज होने के बाद ये √3 हो जाएगा A12. जैसा कि हमने इस जनरल फॉर्म में देखा Aij will be replaced by Abi. So this is very easy to understand. मुझे नहीं लगता कि किसी को भी डाउट होगा ट्रांसपोज ऑफ अ मैट्रिक्स में. So you can pause this video to note this down. So we have seen what transpose of a matrix is. So let us see some properties of transpose. So the first property is that A transpose and transpose of A transpose is equals to A. And the second property is if a constant is multiplied with a matrix and उसका transpose अगर हमें निकालना है, so we can take that constant outside. That means Ka the whole transpose is equal to K into A transpose, where K is any constant. And the third property is if we have two matrix A and B and the operation is A plus B the whole transpose, then we can write it as A transpose plus B transpose. Simple है काफी समझने में. And the last property is if we have to multiply A into B and उसका transpose निकालना है, then that will be equal to B transpose into A transpose. ये इसमें confuse मत हो जाना. This is only for transpose. अगर हम दो matrix का transpose as a whole निकालेंगे A into B as whole transpose, then that will be equal to पहले B matrix का transpose आएगा into A matrix का transpose. So these are the 4 properties of transpose of a matrix, or you can pause the video to note these properties. Now let us take an example to understand it in a better way. So here we have two matrix A and B of same orders, and we have to verify that A transpose and उसका transpose is equals to A. So let's see. A transpose हमने देखा है row is interchanged with column. So यहाँ पे 2 rows है, 2 रोज बन जाएंगी कॉलम्स. तो अब A ट्रांसपोज का भी हमें ट्रांसपोज करना है. अब यहाँ पे 3 रोज है, 3 रोज विल बी कन्वर्टेड इनटू 3 कॉलम्स विच इज नथिंग बट ये तो घूम फिर के हम वहीं आ गए. तो A ट्रांसपोज एंड उसका ट्रांसपोज इज इक्वल्स टू A ओनली. Moving for the second question, A plus B the whole transpose is equals to A transpose plus B transpose. तो अब simply हम लोग A plus B करते हैं. 3 plus 2 is 5, √3 plus -1 is √3 minus 1, 2 plus 2 is 4, 4 plus 1 is 5, 2 plus 2 is again 4 and 0 plus 4 is 4. If you haven't seen the video of operation on matrices where addition, subtraction, multiplication is explained, you can check that video. The link is in the description. So after adding these two matrix A plus B, we have to take transpose of it. विच इज यहाँ पे अभी 2 रोज है तो ये 2 रोज बन जाएंगी 2 कॉलम्स, विच इज 5 रूट 3 माइनस 1 4, ये बन जाएगा फर्स्ट कॉलम, एंड 5 4 4 ये बन जाएगा सेकंड कॉलम। एंड द राइट हैंड साइड ऑफ द इक्वेशन इज A ट्रांसपोज प्लस B ट्रांसपोज करना है, तो अब A का हम ट्रांसपोज करेंगे तो 2 रो बन जाएगा 2 कॉलम, सिमिलरली B का ट्रांसपोज करेंगे तो 2 रो बन जाएगा यहाँ पर भी सेम 2 कॉलम। एंड अगर हम लोग A ट्रांसपोज प्लस B ट्रांसपोज करते हैं दैट मीन्स 3 प्लस 2 5, 4 प्लस 1 5, रूट 3 प्लस माइनस 1 is root 3 minus 1, 2 plus 2 is 4, 2 plus 2 is again 4, and 0 plus 4 is 4 again. So that means A plus B the whole transpose is equals to A transpose plus B transpose. It is verified now. So pause the video to note this down. And the third question is K into B the whole transpose is equals to K into B transpose, where K is any constant. So first we'll write the right hand side of the equation, which is K into B the whole transpose, K multiplying with each and every element of matrix B. And after multiplying K, we'll take transpose of this. यहाँ पे भी same 2 रो है, ये बन जाएगा 2 कॉलम, and that is equals to, अगर K हम सारे बाहर ले लेंगे, so this matrix is nothing but B transpose only, जैसा कि हमने ऊपर फाइंड किया. So that means KB the whole transpose is equals to K into B transpose. So it is also verified. So all the properties are verified now. I hope you understand this concept easily. Now moving for the next topic, symmetric and skew-symmetric matrices. So for the first symmetric matrix, let us see the definition of it. A square matrix A is equals to Aij is said to be symmetric if A dash is equals to A. That is, Aij must be equal to Aji for all possible values of I and J. So for example, A is equals to here a 3 by 3 matrix, and अगर हम लोग इसका ट्रांसपोज निकालेंगे तो भी सेम आएगा. जैसे फर्स्ट कॉलम 2 3 2 3 है, फर्स्ट रो में डालो, सेकंड कॉलम है 2 माइनस 1.5 माइनस 1, इसको सेकंड रो में डालो, थर्ड कॉलम है 3 माइनस 1 1, इसको थर्ड रो में डाल दो 3 माइनस 1 एंड 1. So that means A is equals to A transpose, and अगर ऐसा कोई मैट्रिक्स होता है then that matrix is known as a symmetric matrix. You can pause the video to note this down. So next for the skew-symmetric matrix, इसका definition है that a square matrix A is equals to Aij is said to be a skew-symmetric matrix if A is equals to minus A dash, that is Aji is equals to minus Aij for all possible values of I and J. तो अगर हम लोग इसमें Aji और Aij में if we put I is equals to J, that means यहाँ पे दोनों जगह J will be replaced by I, that means Aii is equals to minus of Aii. अगर हम इसको लेफ्ट साइड लेकर जाएंगे तो it will be 2Aii is equals to 0, or simply we can say Aii is equals to 0 for all the value of i's. That means for all the values of diagonals. तो skew symmetric matrix क्या होता है? So if we take a transpose of A and the transpose become a negative of A, that means it is a skew symmetric matrix, and in a skew symmetric matrix all the diagonal elements are 0. So let us take an example here. Matrix B is equals to 0 E F J minus E 0 G minus F minus G and 0. If we take transpose of this, first row which is 0 E F becomes first column, second row which is minus E 0 G becomes second column, and third row minus F minus G 0 becomes third column. So if we take out the minus sign from B dash, it is nothing but equal to B. So that means B is equals to negative of A transpose, and we can see that the diagonal elements are 0. So it is said to be a skew symmetric matrix. Pause the video to note this down. Now let us see some theorems here. Theorem number 1 is for any square matrix A with real number entries, A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. That means अगर हमारे पास matrix A है and if we take transpose of this and then if we do A plus A transpose, it will be a symmetric matrix, and if we do A minus A dash, it will be a skew symmetric matrix. So let's see the proof of that. Now let us substitute B is equals to A plus A dash. Now taking transpose of this equation, B dash will be equal to A plus A dash, and as we know that the transpose distributes into the bracket, so this becomes A dash plus A dash of dash, and also we know that A transpose ka transpose is equal to A, so that means it becomes A dash plus A. Now we can write this A dash plus A as A plus A dash, क्योंकि addition ही है, हम इसको interchange कर सकते हैं. So we can see that A plus A dash is nothing but B, so that means B dash is equals to B. So B dash is equals to B कब होता है? When it is a symmetric matrix. So therefore A plus A dash is a symmetric matrix. So similarly, we'll take A minus A dash as C and we'll take transpose on both the side. So that means A dash minus A transpose of transpose, that becomes A. And if we take negative sign outside, then it becomes A minus A dash. So A minus A dash is nothing but it is equal to C. So that means C dash is equals to minus C, जो कि हमारा एक skew symmetric matrix का condition है. Therefore, A minus A dash is a skew symmetric matrix. So this is what theorem 1 is, and the proof of theorem 1, you can pause the video to note this down. So moving for the theorem 2, it says any square matrix can be expressed as the sum of a symmetric and a skew-symmetric matrix. So how can it be expressed as the sum of symmetric and the skew-symmetric matrix? So let us take a square matrix A, and if we write it as A is equals to half of A plus A dash plus half of A minus A dash. So this is the expression for sum of a symmetric and a skew-symmetric matrix. So also we know that from theorem 1, A plus A dash is a symmetric matrix and A minus A dash is a skew-symmetric matrix. And also we have seen the property where Ka the whole transpose is equals to K into A transpose. So that's what half is. Half is a constant. That means half of A plus A dash is a symmetric matrix and half of A minus A dash is a skew-symmetric matrix. So therefore any square matrix can be expressed as the sum of symmetric and a skew-symmetric matrix, and this is the expression for it. You can pause the video to note this down. Now let us take an example where we have given a matrix B of order 3 and we have to express it as a sum of symmetric and skew-symmetric matrix. So what we'll do first is we'll take transpose of this, which is B dash equals to first row बन जाएगा first column, second row बन जाएगा second column, and third row बन जाएगा third column. And let us take P is equals to half B plus B dash, which is the case for symmetric matrix, and that will be half is equals to B plus B dash करना है हमें 2 plus 2 4 minus 2 minus 1 is minus 3 and so on. ये addition अगर करते जाएंगे, so this will be our matrix, and after multiplying each and every element of this matrix with half, we'll get this matrix, which is matrix P. And if we take transpose of this matrix P, it will be like this. So this is nothing but equal to P only. So when P dash is equals to P, then it is a symmetric matrix. So that means P is equals to half B plus B dash is a symmetric matrix. And moving further, let us take the case of skew symmetric matrix as Q, which is equals to half B minus B dash. तो अभी यहाँ पे हमें half into B minus B dash करना है, which is 2 minus 2 is 0 and minus 2 plus 1 is minus 1 and so on. The matrix will look like this, and after multiplying half with each and every element, it will be like this. So now taking the transpose of matrix Q, it will be first row changed with first column, second row with second column, and third row with third column. And after taking out the negative sign here, this matrix becomes Q only. That means Q dash is equals to minus Q. This is the condition for skew symmetric matrix. That means Q is equals to half of B minus B dash is a skew symmetric matrix. And now after taking sum of the symmetric and skew symmetric matrix, matrix P plus matrix Q, it will be equal to like this, where 2 plus 0 is 2 and minus 3 by 2 minus 1 by 2 is equals to minus 2. So this is what our matrix B. तो अगर ये operation करने के बाद, which is expressing this B into sum of symmetric and skew symmetric matrix, our answer will be B only. So we can say that B is represented as the sum of a symmetric and skew symmetric matrix. So more of these kind of questions we will solve in our exercise in the next video. So you can pause the video to note this down. So this was our last topic, guys. Now we'll quickly revise today's topics. So the first part, we have seen that a transpose of a matrix, it is that if a matrix A is equals to Aij of order m by n, and if we take transpose of it, which is expressed as A dash or A raised to t, it will be equal to Aj of order n into m. That means the row will be interchanged with column and the column will be interchanged with row. So this is what transpose of a matrix is. Then we have seen 4 properties of a transpose of a matrix, which is A transpose, and uska transpose is equals to A, and K into A the whole transpose can be written as Ka transpose, and A plus B ka transpose is equals to A transpose plus B transpose, and the last A into B the whole transpose is equals to B transpose into A transpose. So these were the properties which we studied, and the next topic is that if we have a matrix A, it is said to be a symmetric matrix if A dash is equals to A, and similarly if a matrix A is a skew symmetric matrix if only A dash is equals to negative of A. So this was the concept of symmetric and skew symmetric matrix, and the last topic which we completed was that any square matrix can be represented as the sum of a symmetric and a skew-symmetric matrix. So these were the topics of today's video. You can pause the video and note down this quick summary for your reference. So that's it guys for today. So the next video will be on exercise based on these topics, which is exercise 3.3. If you are new to this channel, then don't forget to subscribe and press the bell icon to get notified for our every new video. And if you find our videos interesting, then do share with your friends and family, and don't leave without giving a like to this video. So thank you guys, stay safe, study well, and see you in the next video.